All right, let's get right into it. Today, we're looking at a potential breakthrough in AI that's, well, it's about way more than just clever code. We're talking about a blueprint that might actually be woven into the fabric of reality itself. Pretty wild, right?
But before we get to the wild stuff, we've got to start with a huge, and I mean huge, problem. You see, we have these incredible AIs, right? They can write poetry, they can create stunning images, but they all have this one critical shared flaw. The moment you try to teach them something new, they often just forget what they already knew. It's one of the biggest roadblocks we're facing in the quest to create a truly adaptable, continuously learning intelligence.
So let's break it down. Before we can even begin to understand the solution, we have to get a real sense of the scale of this problem.
Just look at the difference here. On one side, you've got the human brain. I mean, that's our gold standard for learning, right? It's constantly adapting, bringing in new info, all while holding on tight to old memories. But then you have the standard AI model, what the source material here calls a unitary AI. And when it tries to learn something new, it runs into a really, really devastating problem.
And that problem has a name that honestly says it all: catastrophic forgetting. And look, this isn't some minor glitch. Imagine you spend years learning how to play the piano, you get really good at it, and then you decide to learn guitar. And after a few weeks with the guitar, you've completely forgotten how to play the piano? That is literally what is happening inside these AIs. The new knowledge doesn't just add on. It completely overwrites and destroys the old stuff.
So why on earth does this happen? Well, the source material points to a core design flaw it calls the unitary fallacy. And this is basically the flawed idea that you can have one single giant interconnected network and just keep cramming new updates into it without everything breaking. You know, it's kind of like trying to add a new character to a finished painting by just painting over a section. You're just going to ruin what was already there.
And the source uses this really powerful metaphor to describe just how violent this process is: a torsional impulse. So think of the AI's knowledge as this beautifully, carefully folded piece of fabric. Well, new training data acts like a sudden, sharp twist that just rips through the entire thing, completely destroying all those delicate, previously learned folds. The whole system just gets corrupted.
Okay, so if one single unified network is the problem, what's the solution? Well, it turns out it requires a completely new way of thinking about AI architecture.
And that solution is a paradigm called nested learning. So instead of one giant unitary model, nested learning builds a system of smaller, interconnected models, a network of networks. It totally reframes the goal from how do we update this one big thing to how do we create a system of specialized parts that can all work together.
So how does this actually work in practice? It's pretty elegant, actually. You have a parent model that basically acts like your long-term memory. It's stable and it changes very, very slowly. Then, when a new task comes along, the system either activates or just creates a child model, this small, fast-learning network designed just for that task. And here's the crucial part. That torsional impulse we talked about, the twist from the new data, it's contained entirely within that child. The parent model stays stable, completely untouched. And just like that, catastrophic forgetting is avoided. Problem solved.
Okay, so nested learning is a brilliant piece of engineering, right? It solves a massive technical problem. But this is where our story takes a really interesting turn, from the world of computer science to something much, much bigger.
So we've established the method works. It lets an AI learn new things without completely trashing its past knowledge, which is a huge step forward.
But that leads to a much deeper question. Is it just a coincidence that this particular structure, this stable parent with flexible children, is the one that works so well? Or is there a deeper, more fundamental reason why this architecture is the only way to continual learning?
Well, according to the source, the answer isn't found in another algorithm or a piece of code. It's in a philosophical framework called the theory of infinity. And this theory claims that the structure of nested learning isn't just some clever hack. It's a computational discovery of a fundamental pattern of reality itself.
Okay, so let's really dig into this. We're going to look at the theory's core ideas, its axioms, and map them directly onto the AI's design. And believe me, this is where it gets absolutely fascinating.
Okay, Axiom 1, hierarchical recursion. The theory says that reality is built as a series of forms within forms. You have a stable ancestor, which it calls the parent golden set, that gives rise to a more local form, the child golden set. Now, does that sound familiar? It's a perfect mirror of the nested learning architecture. The AI's slow, stable memory system is the parent. The fast, task-specific little networks are the children. This network within a network model works precisely because it's following this fundamental, recursive pattern.
All right, Axiom 2 describes this fundamental tension called the mu/nu schism. The theory says reality has two layers, a nu layer of holistic stability, the things that last, and a mu layer of local plasticity, where new things are being formed. This is exactly the stability-plasticity dilemma that has plagued AI for decades. How do you hold on to old knowledge while bringing in new stuff? The theory says you need a stable join to connect them without creating chaos. And guess what? Nested learning's multi-timescale architecture is that stable join.
Next up, we have the Generative Triad, which is basically a three-part creative cycle. It starts with psi, the stable background context that you use for evaluation. In the AI, that's the parent model's stable knowledge. Then you have phi, which is the active formation itself. That's the learning, the gradient update that creates a new skill. And finally, you have theta, the routing principle that decides where the learning should happen. The AI does this through self-modification, literally learning how to route new data to the correct subnetwork. It's a complete computational loop that mirrors the theory's creative process perfectly.
And finally, we have the cosmic audit. This is the mechanism that prevents those chaotic torsional impulses we talked about way back at the beginning from destroying the whole system. In nested learning, this audit is the update rule itself. By having different parts of the network update at different speeds, super fast for the children, super slow for the parent, the system naturally filters and contains new information. It preserves the overall order.
So when we put all of this together, what does it actually mean? Well, it suggests something pretty profound about the very nature of intelligence itself.
The argument here is that these aren't just clever design choices. They are necessary principles for any system that's going to learn continuously. You have to have hierarchical recursion. You need multi-scale dynamics to handle both stability and change. You absolutely must have bounded updates to audit new information before it causes chaos. And the system has to have self-modification so it can learn how to learn. These start to look less like engineering tricks and more like universal laws of intelligence.
This quote from the source material just captures the whole idea perfectly. To achieve continual intelligence, design for infinity. Embrace recursion, embrace hierarchy, and respect the separation of timescales. It's a call to completely shift how we think about designing AI, moving away from building single, static objects and toward creating dynamic, evolving systems that are structured more like the cosmos itself.
And that leaves us with one final, kind of mind-bending thought. We started this whole journey by trying to build a machine that learns, but we found that to do it right, we might have had to build a machine that reflects the fundamental structure of the universe. So if AI really needs the cosmos as its blueprint, what can that AI ultimately teach us about the nature of the cosmos itself?